Okay. So some things we have not talked about in a while. All right, going back to chapter 1. Sequences. We already talked about Fibonacci. Got it written up over there. Remember we talked about arithmetic and geometric sequences. Arithmetic was between any two consecutive terms, there's a common difference. Geometric, between any two consecutive terms, there's a common ratio. This obviously is neither. Now, we came up with a way though that we could figure out the next term. It doesn't work for every single sequence, but it works for a great many. On this, there is a problem that uses this, and it specifically says use the method of successive differences. What was that? Kind of going through like you were seeing if it was arithmetic. Perfectly determined it's not, but take the differences of consecutive terms. So here would be 4. Here would be what, 16, 56 minus 22 would be what, 34. And then 114 minus 56, I'm gonna do that. 58. 58.
Yeah.
All right. Now, what we're looking for normally is a common row of the same number. Every number is the same. Or there, at least there's an established pattern. So I don't see it yet, so I do it again. Now I have 12. Here I'm going to have 18. And here I'm going to have looks like 24. Now when I do this again, I get 6. And I get what? 6. All right. So what we do at that point that I get that common row is assume that the next number is the same. It's a 6. And I can build backwards. So I would have what? 30, 88, and 114 plus 88. 202. Okay. And I've got the next term. All right, good. Method of successive differences. So there will be a couple questions involving inductive reasoning and deductive reasoning. Remember, inductive is I look at a series of examples and use those observations to make a prediction about what's going to happen next. Deductive, I apply generally held rules, laws, etc., to make a conclusion as to what is going to happen next. Specifically, you'll hear these terms associated with inductive reasoning. I look at specific examples to make a general conclusion. Deductive, I look at general rules apply and apply them to a specific conclusion. So, all right. Also within chapter 1, figure numbers, which were sequences, octal, hexagonal, octagonal, nonagonal. There's a couple questions related to those. They're pretty straightforward and easy. And so that was chapter 1. There are no questions or problems from 1.3. That was the problem solving section. We had all those crazy problems. All right, so there won't be any from there. So remember, kind of 4-step problem solving strategy. Understand, plan, carry out. Once you make your plan, then carry out the plan. Number 4 was look back and check. Or problem solving steps. Okay. So, geometry, which was chapter 9. Okay. So, and I should also point out all 32 problems on the review, you've actually already worked all these problems. They all came from Hamilton. Review homework problems. Now, of course, the numbers will be different and so on and so forth, but the problems themselves are the same. Probably easiest way to tackle this. Stuff. There's the stuff we just finished. Okay. That's the first. Okay, so this is actually in the review assignment itself. This is the geometry. And it says here, use the figure to find. What's that book symbol? I'm sorry? What's that book symbol?
It looks like a fishing boat. What's that supposed to be? Or is that supposed to be?
Right here?
It looks like part of the line. Or is that supposed to say union?
That is supposed to say. union.
Okay.
So,
Never mind.
and I noticed that myself, but they're, so it combines
Okay.
what,
I thought it
set
looked- The
operation.
way it was spaced, I thought it was something different.
Yeah, but this is a line segment, right? B, Y. Union with Y, what? Z. Now, if you're making you're doing, you don't necessarily have to put those little points here, just a straight line across. But it says use this. And it gives you a line and gives you the points what B, X, Y, and what point Z. So it says come up with, if you union these two together. Now BY is what right here. YZ is what right here. So if I union these two together, I'm going to have what? Easy. And let's look. And now you got to be careful. What is that? A. It's array. Remember, array. You do that. It goes only one direction. So, what was C? Selection C.
That doesn't include the.
It doesn't include the endpoints. They do that. What was that thing called? We never used it other than when we first introduced it. Well, I should take that back. We never even talked about something like that. We did that. What was that thing called? Remember the term half line? That's a half line. What they're giving to you is a segment whose endpoints are not what included. So be careful. You want that. Should be A. Or B, excuse me. All right. Okay, what is complement?
Either 90 or 180.
Okay, so remember that. So complementary angles. or supplementary angles, right? Those were the two. They're both pairs. In one case, the two pairs add up to be 180 degrees. The other one, they add up to be 90 degrees. Complementary add up to be 90 degrees. So if you have find a measure of the complement of 66, just go what, 90 minus what? 66, which would be 30.
24.
24, 20, 24. 24. In that case, it would be 24 degrees would be its complement. All right. So, all right, I took the word problem out involving complementary and supplementary. But here you're setting up linear equations based on geometric principles. Now, what they don't say in this problem is what this is, what the situation is, what the geometric concept is. Two lines which intersect to form what? Non-adjacent what angles? All right. Now notice I didn't say anything about them being equal in measure. I just said the non-adjacent angles formed by the intersection of two lines. They got to be, that means non-adjacent, they do not share side. What was the name of the pair of angles? Either this pair or this pair. Began with the letter V. Vertical. Vertical angles. Vertical angles is this situation. Then by theorem, we find out they're congruent, or you can say equal in measure. So you were right on point when you said what? Set the two expressions what? Equal to one another. And so in one you had 4x plus 45 degrees. The other you had 8x plus 9 degrees. And so you would just say 4x plus 45 equals 8x plus 9 and solve. I bring this term to this side, which would give me 4x, subtract it, 4x from both sides. Subtract 9 from both sides, and I'd have what? 36. And divide both sides by 4 to isolate x, which would give me x to be what? 9. Now, also, it didn't ask you to solve for x. It asked you to find what the measure of those angles, which you know has to be the same. So once you find x, plug into either one of them. And so like in this case, I could just go 8 times what? 9 plus what? 9. 81. So that's going to be what? 72, and that's going to be plus 9, which would be what? 81 degrees. That would be your answer. Notice you don't have to put the degree notation in, they do that for you. Okay. This one, convex, and I actually gave you another term for not convex, concave. Well, what do you think here? What's your gut feeling? You got a 50-50 shot here.
Is vex like not inward?
Not inwards, a good way, you can think of it that way. That's a very simple way to think of it. It's not what caved in, right? So this has got to be convex. Okay, let's talk about geometrically what exactly makes it convex. You have a figure such as this. Might call it an ellipse, squash circle. That's not actually a geometric term, but an ellipse. When you go to determine, is this convex? Then any 2 points you pick on the interior of that figure and then connect them up with a line, so you got a line segment, all those points stay on the inside. But if it's caved in somewhere, say that is quadrilateral, I can pick 2 points, and when I connect them up, some of those points go what? Exterior. There's where you got concave. Or not convex. All righty. Okay, types of triangles. Now, the three terms you see here, scalene, equilateral, isosceles. This deals with classification of triangles by size. What was scalene? When you hear a triangle is scalene, what do you know about that triangle?
All sides are different.
All the sides have different lengths. If it's isosceles, two of the sides have the same length. And if it's equilateral, all three sides have the same length. If it's equilateral, what has to be the measure of all three interior angles? 60 degrees. Since they all three have to add up to be 180 degrees, and they all three have to be the same. If you have an isosceles triangle, which means two of the sides have the same length, we call, and this has something else, we call these two angles down here the base angles, and they have to be what? The same. And then this is something else. Okay, so in this case, what do I have? It's isosceles. Two of the sides have the same length. Okay. Now we have classification what to angles. If it is a right triangle, one angle is what? Right angle, it's 90 degrees. If it's acute, all three angles are what? Are acute, which means they are all less than what? 90 degrees. And you can just strictly say that because in Euclidean geometry, all measures have to be positive. They cannot be zero. They cannot be negative. Now, if you take a trig class, it's a different story. But for geometry, they all have to be everything has to be positively measured. So an obtuse means an obtuse angle is between 90 and what 180. So an obtuse triangle has to have one angle that's obtuse between 90 degrees and 180 degrees. What is an angle that measures 180 degrees? What do we call that angle? Straight. Well, I just call it a straight angle. Straight angle. Okay. So this particular triangle, what do you think? What's it look like? Looks acute. I mean, just visually. All three angles definitely look like they're less than 90 degrees. So we'll go with acute. Good old circles.
I didn't see that.
They cannot.
Oh.
No, they cannot. It's part of my limitation, which is I'm working on trying to problem solve for that. Unfortunately, it just is what it is. So you have to kind of just, that's why I'm trying to write things up on the board. And the only thing I've done is I've taken the camera, but what happens is you get this first line running and it doesn't pick it up very well. I've looked at the videos. So what I need to be able to do is get that onto their screen.
There's a way.
There is a way to do it, but yeah,
Yeah, there's a way.
but I'm also,
On two different.
yeah, right now I'm on two computers and I don't, so I've got my math lab there and I don't have any power. I'm off battery right now. So that would probably eat up my battery more than, it usually eats about half of it for a class. But anyhow, that's why I'm putting it up here. So circles. Just terminology. This is a terminology question. The center of the circle doesn't have to be labeled O, but normally if you're just dealing with one circle, it'll be labeled O. Right? And remember what a circle was, a set of points, all the same what distance, or we call equidistant from some fixed point, which is the what center. So you go here and find the center of the circle. Oh, let me attempt to reproduce this. Point A. See a line kind of doing that. Point B here, and a line doing that. They put a point E out on this line. I got D, this is point B here. Then a point here, that's D. Point C here, and then going from, well, that's not gonna work. Point C, and then a line coming that way. And it also looks like the A, B, B, C. Pretend that was it. Okay, I think I got them all. Okay, so the first question says, find the center of the circle, gives you 4 choices, C, O, B, A, pick O. Okay, next thing, says find radii of the circle. And there's multiple radii here. So remember, that is the what? A segment from the center to a point of the circle, and all radii are congruent. So when I look at this, it would have to be what? AO, BO, CO, and what? DO. Now, can I invert those? Yeah, I could call them what? OA, OB, OC, and OD. Remember, for line segments, the order of the points does not matter. And that would here be selection what? C. All right, so that's all your radii. Now it says find the what? Diameters. Now, diameter is twice the what radius in length. And they haven't asked us to find chords yet, but a diameter is a chord. What's a chord? Line segment whose endpoints are points of the what? Circle. And it goes through, if it goes through the center, then it's a diameter. So a diameter is a chord that happens to pass through the center. So that would be what? AC and what? BD. That looks to be selection B. All right, now it says find the what? Chords. All right, looks like, now remember, that's just a line segment whose endpoints are points of the what? Circle. AD. BC would be a chord. And I believe that's it. So it looks like in this case, what? B. Did I forget one? I think they made me count the diameters.
I think we're counting A.
Looks like it's off of them.
AE is not a chord. With that, I'm sure. AE is not a chord. I think what they're doing is counting the diameters. Notice there's one choice that has what? 4 of them, and it has a, does it have, it does have AB, and it does have what? BC. So I don't necessarily agree with this one, but when you do the problem, right, looks like it's gonna be this. So what they've done is, because a diameter is a chord who happens to pass through the center, they're throwing that into the list of what chords. Right, so, okay. Now I want to find the secant. A secant is a line which passes through what? Now it's got to be a line, and it passes through 2 points of the circle. So notice here's a line what? AB, and line what? BC. Those would be your 2 secants. AB and BC, that looks to be selection C.
What's the difference between chord and secant again?
Chord is a line segment.
Oh, that's the only. Okay.
So visually, you gotta see those in what arrows, which means it goes there.
So if it didn't have that, it worked out.
That's
Okay.
AB, yeah.
Okay.
So a chord is a line segment, a secant is a line. Now tangents. Tangent is a line which passes through what? 1 point. They wanted to name them by points. That's why they put the point E in. So it's AE. And there's only one tangent here, is this one. Okay. Good? All right. Here, we are dealing with similar triangles. Similar triangles. And remember the word proportional. So similar triangles have side lengths, which are corresponding side lengths. If you got two triangles that are similar, they kind of look the same, but one's what, a smaller version of the other. And if you take the corresponding sides, they're what we call proportional. What about the corresponding angles for similar triangles? They are exactly the same. They're equal in measure. So if I was looking at this one, it says enter the missing angle measures below. Draw it exactly the same, but this one is said to be 35 degrees. This one doesn't look exactly right. It's 64 degrees. Notice then these two it's saying is the same. Okay, I think that will. No, hold on. I should have done that. I apologize. Let me just draw exactly how it looks here. So I got this, I got this. This they say is what, 35 degrees. Here's T. Here is X. They tell you this is 64 degrees. Here's Z. Here's W. They don't tell you what these are. We asked for a measure of angle T, measure of angle W, measure of angle Y, measure of angle C. All right, so T has to be what? 64. It's corresponding angle there. W, which is what? Here? That point right here is what? This is B, and this is Y. Okay, so now, basically what you can do here to get W is if that's 35, and we just concluded T has to be what? 64. What then does that have to be?
71.
All right, and how did you get 71?
64 plus 35 is 109.
From 180, right? 81?
64 plus 35
Yeah,
is
no, yeah.
99.
I've done that twice.
That's all right. But the concept was all three have to add up to be what, 180. So if you got two of the three, you can find the fifth.
Make sure you can type it in the test.
I definitely.
I'll do it again.
Definitely. 81 what degrees then for what? W. Now Y has to be what? 35, it's corresponding to that one. And then Z has to be what? 81. All right, similar triangles. Let's find side lengths. Here you write out, I'll go ahead and do this one. You write out a proportion. So side lengths are proportional, corresponding side lengths are proportional for similar triangles. So they give you one, roughly looks like this. They give you that. They give you that. That's actually all you need to show two triangles are similar. Two pairs of corresponding angles congruent, because the third has to be at that point. If they give you 3 and 2, they give you 9 and X. So you can write this up a variety of ways. I'm just gonna do this. 3/2 has to be the same as 9/8. You keep the corresponding sides lined up this way. Now, cross multiply. 3x equals 9 times 2, which is 18. Divide both sides by 3, and x is what? 6. Thank you. 3 divided into 18 is 6 times. So it is 6.
It must be giving you my bad mental match.
When I start trying to hurry, that's when bad things happen. I have, and that's like applies to everything in my life. If I'm working on the house, trying to do plumbing or trying to work on the car and I try to hurry, bad things are gonna happen. So you always gotta slow it down. Okay. Now, this one, area. So it actually says find the what circumference and what area of a what circle. So let's just first remember the two formulas. So circumference is what? 2 pi times r, where r is the radius. Area of a circle is pi r squared. All right, so they give you a circle. Equal that. Somewhat there. All right, and they give you this right here, which is the center. And then they say 26 what yards. Now, where they put it, they're talking about the diameter. So if I go find the what circumference of this, I gotta first make sure I have the what radius. So the radius is what? 13. All right. Also, it says type an exact answer in terms of pi. That means don't get the decimal approximation. Leave it as pi. So your circumference would be 2 times pi times the radius, which is what? 13. Now you can go 13 times 2, which will be what? 26. And then what? Pi. And it is circumference, so the unit is linear, you just say yards. So that is all the way around. All right, so you will type in 26 pi. Thank you. We'll definitely be wrong with that. Okay, got it. Now, when now it says what, rounded to the nearest 100th, that's 2 decimal places, so 26 times pi. .68. Still just what, yards. Okay. Normal rounding applies. Okay, now the area, if it wanted those exact value, you're going to go to area, and now it's pi times what? 13 what? Squared. Now, so that would give me what, 169. The units are squared yards. 169 what? Times pi. So 169 times pi, and then squared yards. And then 169 times pi. And rounded to 2 decimal places. 530.93. And still squared yards. That's it. And I think this is the, okay, we're gonna go 2 more. This is area here again. Called composite figure, but it's made up of a parallelogram and a what? Triangle. So we've got to remember the area formulas. Parallelogram is base times what? Height. Triangle area is 1/2. Base times what? Height. Right, so what I would do here, got that parallelogram, and we've got this triangle. It gives you this, which is the height of the triangle. It gives that height to be 4. It gives, well, sorry. I can draw this. They have it. Gives the height of the parallelogram to also be what? 4. Gives you this side length to be 8. And then that's all I need. So for the parallelogram, I'll put A sub P, area of parallelogram. So you're going to find each area individually. Area of the parallelogram would simply be a base of 8 times a height of 4. Now, whatever the units are, is 32 what squared units. So units squared. Area of the triangle is 1/2. Now, the base length has to be what? 8 of that triangle. Since what opposite sides of parallelograms are congruent. And so it's 1/2, 8 times 4. Or 1/2 of 32, which would be what, 16 square units. So your total area has to be 32 plus what? 16. And units squared. And 32 plus 16 would be what, 48. So putting in the answer here would be 48. Notice they give you 3 options. You want units squared. Okay. I did that. That was question 32. What? No. Oh. I guess that's it. All right. Having so much fun, I wanted to do more. So the one thing and I had it in there originally, I must have scrapped it. Spatial figures. So I'm not going to add any more. It is what it is. Just don't forget about solid figures. And now solid figures, what are the units? And what are you looking for? Not area, but what? Volume. Now, if it is what we call say like a cube or polyhedron. So made up of what you can find the area of what each side of that, right? Now, if it is a sphere or a cone, things like that, obviously you're not going to find areas of size, but you can find surfaces on the outside, and those would still be square units. The space that takes up the inside, you are going cubic units. And But that is it. We pretty much have reviewed everything now between the 2 dates. So, let me turn off